Okay, so hello everyone. So normally this will be introduced by a colleague of mine. However, there's been some issues, setting up the links for people. So I'll try my best to introduce everything to all of you. So first of all, welcome to the course. My name is David Stillwell. You've seen me in plenty of videos by now. So I hope you're looking forward to this session and being able to see me live. And perhaps more importantly, send your questions, send your comments. So what I'm going to try and do is make the most of this opportunity to have the live part of this live webinar. So the less that I can talk from my prepared set of information, the better. So don't feel afraid at all. You've got some links at the bottom. So one of the links you've got is to a chat window. So if you click on the chat button, you can send a message to all panelists and attendees, and that should go out to everyone. Alternatively, there's another link which is Q&A. So if you click on Q&A, you can send a question which then gets sent to all of the panelists, which right now is me, and they will be kind of collected together. And what I'll be doing is I'll be mostly monitoring the question and answer section, a bit more than the chat section, just in case it goes a bit quickly. So as far as I can see, there's about 50 people online right now. So in case it goes too quickly for me to keep up with, I will monitor the Q&A. So as I said, do be encouraged to send me any of the questions, and I'll try and answer them as I go through. Some of them I'll try and answer immediately, and some of them I might pull together towards the end to bring it all together. So I guess the topic of this webinar is about it's about big data in the news. So given that we're live, I thought it might be nice to talk about some things that have happened a bit more recently. Oh, good. Okay, great. So someone's already asked a question in the Q&A, so at least it's working for someone, which is good news. As I said, so I'll be talking about some things that are in the news. I think the important thing is, as a manager of this, one of your responsibilities is to keep in touch with what's happening. And there are, quite a few ways of doing that. And actually, it's quite difficult to keep in touch because this is such a, such a topic that is constantly changing and updating. So that's one of the reasons you might have noticed in the content itself, in the videos themselves. A lot of what I'm talking about is things from news articles, things from blog posts, things, even from things that people have tweeted. And you might be thinking, well, this is not rigorous academic content because, academics published in journal articles. But it takes so long for something to come out in a journal article, never mind a textbook, that this stuff is often out of date. So, if you think about an academic doing a piece of research, they might think about what they want to research. Then it takes them at least about a year to get funding to start the research. Then it takes them a couple of years to do the research. And then it takes a couple of years to publish that research by the time you go through the peer review process, which means actually from the time they've had the idea to the time it gets sort of made available in a journal article is, at least sort of, 3, 4, 5 years. Never mind if it gets into a textbook, which is, sort of almost a compendium of journal articles, that's another couple of years before it arrives there. So big data is just moving so fast that, you have to keep updated with the latest in different ways. So I've got some slides here, and I'm hoping that they will appear on the screen, or do I need to press, oh, there we go, share my slides. Okay, great. So I hope you can see those. So the topic of this session is, keeping up big data news. So here's some suggestions from me about places that you as a manager might go to find out, how are things changing? What is the latest? So one good place that I quite like is a place called Data IQ. So they're really sort of data specialists, and they specialize a bit more in the legal side. So some of the discussions about GDPR and what's the latest cases, and who is the European Union sort of, what kind of issues are they looking at right now. Following their newsletter is a really great way to keep updated with that. Another organization, Cognition X, they send out a nice newsletter on a bit more on the sort of opportunities and things that you can do with big data. Another opportunity is from television. So in the UK, you can see BBC Click, which is a weekly tech show. Otherwise, these are people that I follow on Twitter in the bottom left there. So they're all from various news organizations, and these are people that I've seen seem to be genuinely sort of tech experts in terms of latest uses of data and what's going on. So there's a lot of news that does get published that might be from people who are not, really experts in this, but these are people that I quite like. Another place you can potentially follow is I keep an updated list of references or things that I've found interesting that I just add to basically a library or a reference list. So this mix.com/my name David Stillwell, I update from time to time with just things that caught my eye and that I find interesting. And I also categorize them into, so I think you've been going through the 4 V's of big data. So there's a category for each V, and there's a bunch of other things as well, deep learning and some online demos and things like that. So that's a place to potentially get some updates as it goes along. I don't really do podcasts that often, or using LinkedIn to follow, but I think that's also a great resource to find out what's going on. So I do encourage in the chat. So if you send your message to everyone, then do write in the chat some places where you get updated with the latest that's going on with big data. So then other people can see what you recommend, and conferences and things as well. Okay. And you can put them in the Q&A as well, but if you put them in the chat, then everyone can see them, and I think only I can see the Q&As. Okay. All right, so let's start with one thing that caught my eye a few months ago, is, what's the latest on GDPR? So General Data Protection Regulation. This is the regulation that Europe has brought in around use of data. And the legal side of that, and what responsibilities do companies have. And to be honest, so GDPR came in about May 2018. And when it came in, people were sort of saying, and this is what I expected, that because the legislation was really sort of such a step and so new, that the regulators would go quite easy, especially at the beginning, and then over time, as companies are still lagging behind, that they might go a bit harder as they go along. But what seems to have happened is that, so you can see here, there's an FT article about British Airways being fined. So I've got the number written down. They were fined £183 million by the UK's data regulator. And another one was Marriott International. They were fined £99 million. And both of those for data breaches at their company. So not looking after data as carefully as the regulator said that they should. It's a real big step up from the previous regulation in the UK, which was the Data Protection Act, where the maximum fine there was something like £500,000. So now we're up to £100 million. And this surprised me, to be honest, because, as I said, my expectation was that they would start fairly easy and then ramp it up over time. But actually what's happened is that they are sort of making a point, even at the beginning, which I think underlines the importance for companies to, take GDPR seriously. And these fines are, something serious as well that, can affect a business. So the maximum fine that they can do, according to the regulation, is 20 million euros or 4% of turnover. So it's global turnover for a company. So that 4% of turnover is potentially a huge amount for a big company. Okay. Let me just quickly have a look at the Q&As to see if there's any. Okay, so textbooks that I recommend. So yeah, so someone asked, appreciate the lag in the literature point. Are there any textbooks that you would recommend? When I teach my MBAs, I sort of have on the list, there's a textbook called, I think it's Data Analytics for Business. So I can share the reference for that afterwards. That is a reasonable textbook. It came out at about 2012, 2011. So it's reasonable insofar as data analytics. It's not so well on the next step in terms of big data, some of the deep learning stuff, so some of the really cutting edge things. But it's good insofar as, it teaches some nice analytics sort of up to a point. So there's another question, will the slides be available afterwards? Yes, definitely, I will share the slides afterwards. Okay. All right, so this next slide, so right to data portability. So the reason I talk about it now is that often companies see GDPR just as a threat, just as legislation that can be sort of used when, when the government says that things have gone wrong. But actually, it also comes with opportunity as well. So one of the rights that all EU citizens have, or anyone whose data is being processed by a company that's located in the EU, they have the right to what's called data portability. So what this right gives each citizen is a right to ask a company for a copy of their data, and the company is required to give that data in an electronic format that can be taken elsewhere. So a sort of a widely used electronic format like CSV or XML, something like that. And the company is required to give that data. And part of the reason why people to limit some of what seems to happen in terms of when you start working with an organization and you start uploading your photos to Facebook or writing your tweets or writing your information on LinkedIn or whatever it is. And then it's very difficult to switch if you decide that you want to change your social network or if you want to change the company you're working with. So this right to data portability means that the company has to give you your data so you can take it elsewhere. So the opportunity there is if you're a company that's thinking, well, wouldn't it be great if only my users who, 60% of the population of the whole world, well, at least the Western world, is on Facebook, for example. So wouldn't it be great if they could get their Facebook data and share it with my company? So the answer is, actually that can be done. So, for example, we use it on our website, this applyMagicSource.com at the bottom. And there's a sort of a video that tells you how to go to Facebook, download your data, and then upload it to our website. And what we do is we give people some sort of more deeper insight into that data. So what might it say about their psychology, or what might an algorithm predict about their age from this data? And I thought that, this process would end up being far too difficult that no user would actually do it in practice. But actually, we've had hundreds of thousands of people going through this process and following this little video here. So people are willing to do it in practice. So this is not just a theoretical thing; it's an opportunity for companies. Okay, let me check the Q&A again. Okay, how are the algorithms built specifically? Are these developed in a particular language program to query a database? That's a huge question. So how are algorithms built? So what I'm going to do at the end of this webinar, or sort of a few minutes before the end, is I'm going to show you a piece of code for getting data from Twitter. And the reason I show you is not because you have to do any coding or anything like that. It's just to show you why here's what a data scientist is doing when they're writing code and getting data from places. And here's what it looks like, what they're working on. So that is one particular language. It's called R, so the letter R. But there's lots and lots of other languages. A well-used one is Python recently, which is very popular. But ultimately, you know, there's at least tens of popular languages. So it's really kind of up to the data scientists what they have expertise in and what they want to actually use in practice. Okay, so let me show my next slide. So this is, you know, thinking about, you know, as I said, things happening recently that caught my eye. So this one is, you know, well, as you can see from the title, so Chinese subway experimenting with facial recognition to pay for fares. And you know, I've seen in the news over the last few years how, you know, and of course, when you go through the border, there's now often this facial recognition system that then decides whether you can go into, you know, whether it thinks you're the person whose passport that is being scanned, rather than having a passport person look at your face manually. So I knew that, you know, facial recognition was, you know, being deployed in practice. However, the reason this caught my eye is that it's a much easier question to say, well, I'm going through some passport gates. Is that person in the picture the person who's standing there? Right? Because the reason that's easier is because you're looking for a specific person. So your question is only, is that the person or is it not? So it's either a yes or no question. So you can train an algorithm to answer a yes or no question, and that is, you know, much easier than what this facial recognition system is doing, which is that, you know, you don't have to scan anything to say who it is. You just walk through the turnstiles and it looks at your face and it says, of the, you know, 15 million people it could be, you know, especially in China with big cities, of the 15 million people who could be going through this gate, which one of them is it? And that's a very, very hard question, because the chance of, you know, making a false guess could be quite high. So I was amazed that facial recognition is apparently getting to the stage where, you know, it can recognize one person from millions and not just is it that person or is it not? Okay. So this one also caught my eye. So this is from the you know, the government sector, which is not traditionally known as being you know, very innovative. But actually, I think this is something that I thought was quite innovative. So the UK government, they put out economic statistics. You know, they update the GDP numbers every 3 months or so, and so what that means is, you know, the statistics don't come out that often, so there is a lag. But what they've got is they've got a new data science, essentially department in the Office for National Statistics. And what they're doing is they're saying, well, can we come up with faster indicators of economic activity? And not just faster indicators, but can we come up with these indicators in an automatic way, based on kind of real data rather than based on, you know, sending out more surveys. And they've come up with a few examples that they've put into practice, and you can look them up every month. So one of the examples I quite like is the second one down. So number of goods vehicles on the road. So they already have CCTV cameras on highways. And so, you know, because they're already looking for how much traffic is on the road, you know, those kinds of questions. So all they need to do is, you know, if you attach that to some kind of object recognition algorithm, you can then say, well, this is a lorry going down the road. And that's then a fairly short step to, well, if there's lots of lorries on the road, then that's a lot of economic activity. if the number of lorries seems to go down, then probably the amount of economic activity is also decreasing. And that probably says something about GDP. So what I like about this is, as I say, it's an automated thing. They can put out the number each month. I mean, if they really wanted to, I would have thought they could put it out, almost every day, or so almost in real time, how much activity is going on. But obviously on a daily level, you'd get a lot of noise there. But it's using data collection and infrastructure that's already there. This next one down then at the bottom, international ship tracking to measure imports. I quite like that one because, when you put a ship out of dock, you already say, well, here's where it's heading towards. So therefore, instead of waiting for the ship to arrive in the port to say, well, how much goods have just been imported into the country, you can predict how much is likely to get there because you already know how many ships are on their way. That's obviously faster than waiting for it to actually arrive, because if it takes 3 months to get to the UK from China, you can say, well, there's a ship on its way already, and therefore the economic activity is about to happen even before it actually does. Okay, let me go back to the Q&A. So I saw there's another couple of Q&As. Okay, so I understand the scope of this course is not technical, but will we have an overview of how to use programs such as R or Python and interpret the results? So you're completely right. So the course is not a technical one. So as I said, when I show you this R screen later and some of the codes, don't feel anxious about it and feel like, next week I'm going to get you to write lots of code or anything like that. What I will be providing and what is in some of the links are sort of references to much more sort of detailed things about, well, if you wanted to learn to code in R or to code in Python, and put some of the things that I'm going to tell you about, such as machine learning and predictive analytics, which comes in a few weeks. If you wanted to actually sort of be a data scientist and put that into practice, then here's a place online where you might go to collect this kind of to get this kind of knowledge. The other alternative that I sometimes recommend for people who actually want to become data scientists rather than just work with data scientists is they have organizations, certainly in the UK, and I'm sure in other countries as well, because it's a well-used model, where what they do is they take people who've got some kind of quantitative experience, but haven't necessarily learned about data science and the very technical sort of latest developments. And what they do is they put them through a boot camp. So you go to this boot camp for 8 to 12 weeks or so. They teach you the latest of how to do some of this data science in practice. Normally it's in collaboration with companies that provide data. And then afterwards, their goal is to get you a data science job. And it's a bit like a recruitment specialist. They get paid based on a percentage of the salary once the people on their cohort find these data science jobs, which means the positive side is you don't necessarily have to pay for this workshop, because you pay by getting a data science job and then they get paid that way. So I like the sort of alignment of its incentives so that it's good for the person looking for a job and it's good for the person, and it's good for the company, teaching these things. Okay, so next question from Ananda. Okay, so sorry, lots of questions appeared and I'm now out of sync. Okay, young centennial populations appear to be much more comfortable sharing private data as they expect this will be used to serve more personalized products and services. Is the ethics point out of date? Yes, so how do people feel about use of data? And that's a great question. And at the end of this course, so in the final week, there's a whole section on using people's personal data and what are the ethics around that, and how can you use data in a way that makes sure that people are comfortable. I've had some experience myself. So I did a piece of research on predicting people's personality from their Facebook data. And some of you may have heard of a little company called Cambridge Analytica, which I was nothing to do with, but they used my research for something that many people would say was unethical. That point will be brought up again. And in fact, the final webinar that you're doing with me is we'll have a discussion on the ethics of using data and how to make sure that people are comfortable. Okay, so next question down was, do you have a recommendation, R versus Python? I noticed that Python is the most popular programming language. Great question, Graham. So my answer is probably if I was starting to learn now, I would use Python myself. However, I happen to have a background in R that I've been using for 6 or 7 years, so I tend to use R myself. I think the reality is it probably doesn't make that much difference, because a lot of what gets written about, what gets created for R ends up being ported to Python, or what gets created for Python ends up being ported to R. So apart from some areas when you're doing sort of very, very cutting edge stuff with deep learning, perhaps, Python is a bit better when you want to put something into practice. So R is good if you just want to analyze some data and get some insights. But if you want to produce some kind of app that works on the web, then Python in general is sort of set up to be a sort of programming language that can be deployed into practice, so actually put on a website. So if that's the goal, to create some kind of app, then Python is a good way. Okay. So Ananda, what is the unit of economic activity that is substantiated with these kinds of new data points, like freight vehicles or lights on? So yes, so the trucks going down the road, or lorries going down the road, they're literally just counting the number of lorries. So you could say, well, what happens if a lorry is half empty? And indeed, the data, this kind of data wouldn't be able to pick up whether a lorry is empty or full. And same thing with the ship that's on its way that hasn't arrived yet. That could be empty or full as well. So this isn't perfect data, and that's why ultimately the surveys and the actual sort of careful measuring is still going to be used. That's still going to continue on into the future. However, if you want kind of faster data and data that might be a bit messy, but it comes much quicker, then these kinds of big data sources are good ways of doing that. Okay, so plenty of other questions. Thank you for those. I'll get back to them in a second. Let me show you my next slide. Okay, so I wanted to show this one, and I hope you can see the animation that's on my screen as well, because I noticed this in the FT just a couple of weeks ago, where they're talking about use of big data in sports. So you've probably heard of the book and what became a film called Moneyball, where they did data analytics for baseball in the US. But what amazed me with this article is that the thing about baseball and something like American football as well is there's a nice point where the game kind of gets reset. So the player comes up to the plate, it's sort of almost a reset, albeit you've got players on the bases. And the same with American football, the game sort of gets reset every time there's a new play. And at the time, people were saying, well, this data analytics stuff, it works fine when you've got a nice sort of reset happening so that you can sort of start the analytics from a particular point. But what they're doing now that surprised me is they're doing it even with fluid games like soccer or what me as a British person would call football. So you can see this animation down the bottom, and what they're one of the things that they do, for example, is they look at based on where this player is on the pitch at any one time and where the ball is, how much space is that player generating around them. And you can see these shapes sort of being generated and moving around as the player plays. And then they can see, how good is this player at creating space, at moving in the direction that means that, he or she is able to get this space around them so that they're part of the game. And indeed, they go the next level and they say, well, if we're trying to get a new player on our team, we're deciding who should we sign up to our soccer team and who should we pay, millions and millions of pounds to sign. They actually simulate how would the current team be, how would they perform if this player was on the pitch, just based on their predictions of how this player is able to find space and what are they likely to do given the ball is in this place and they've got this much room around them, and would they turn left or right, or would they jog or sprint or whatever it is. And then they're able to simulate, well, given a certain situation, would this player actually gel well with the team? So of course you can measure, well, how many goals do they score? But the real question is, how many goals would they score on my team? And some football clubs are even, according to this article, they're actually plotting players on how good would the player be for the team, how much does the player cost to sign, and then they're trying to sign a player that's, as cheap as they can get, but also would be incredible on their particular team. And then they're choosing those players who fit that. So the most expensive player is not necessarily the best player for your team, depending on the way that your team plays. And I just like that as I said, as a demonstration of real fluid analytics rather than just a one shot, a bit like, will someone pay back their loan? Yes or no? This is very different from that. Okay. All right, so I'm going to talk about generative adversarial networks in a minute, but let me do some Q&As first, see what the latest is. So Kathy says, can SQL provide any similar outcomes with R and Python, with what R and Python do? I'm wondering which might be the best one to start with. So SQL is a database sort of query language. So if you've got a database, an SQL, so it means structured query language. So if you've got a database that's structured, so if you've got columns and rows, then SQL is a way to get out particular data from that very structured database. So, a bit like getting data from an Excel sheet by saying I need row 13 and column C, then you get that data. What SQL doesn't particularly do is analyzing that data that you've gotten out. So it won't be able to do any machine learning with that data. It won't be able to predict what might happen. What it does is it gets the data. Now, I think SQL is very good to know because, if the first step of doing any data analytics is getting data from somewhere. So SQL is the good first step to do that. Okay. So Graham says, any examples of companies running the data science boot camps? I can give you some examples because they keep emailing me and saying I recommended people in the past and can I recommend new ones. So I can check my emails and make a few suggestions for you. Okay. Okay, so Kathy at the bottom. So is artificial intelligence and machine learning one of the same? Now that is a very controversial question. I'm not sure if you know how controversial this is. I subscribe to the view that if you think of a circle, then artificial intelligence is like a big circle, and machine learning is a circle within that. So machine learning is part of artificial intelligence, but artificial intelligence is broader and encapsulates other things. So what machine learning does, and you'll hear all about it in the machine learning weeks, is it's really good at taking a bunch of data, messy data from millions and billions of people, and predicting stuff with it, right? So the only goal of machine learning is to predict something. Sometimes that looks a bit like artificial intelligence because, for example, a machine learning algorithm goes, well, given the 3 words that you've written, which word are you likely to write next? Okay, so it's given this data, what is likely to come next. So that's machine learning, but then you sort of deploy it in an artificial intelligence way because you say, well, if I tried to get a machine to write a poem, then if I give it 3 words at the beginning of a poem, then how would it end the poem? How would it continue it on? And that's sort of what we think of as, sort of an intelligent agent coming up with something creative and new. So it's deployed in an artificial intelligence way, but the sort of the technology behind it is machine learning. So AI for me is broader than machine learning. But on the other hand, plenty of people would say that they are the same. Okay, let me show you this with generative adversarial networks. So, sorry, I'll just press the button a couple of times. Okay, so these are interesting because you've probably heard of things like deep fakes and and those kinds of things. So what is a generative adversarial network? It's something that can create these things that you might have heard of. So what how does it go about? Well, let me start with a demo, and then I'll talk about how it actually a bit of the intuition. So here's a demo. It's a web page, and you can go to this web page as well. So this person does not exist.com. So if I go to that web page, and I'm hoping you'll still be able to see my screen, I might have to press a button to make that possible. So let me just copy that link. Okay, Dave, can you give me a nod if you can see this this lady on the screen? No. Okay, so let me make sure I press the button to share this screen.
Yeah, just share the other. It should give you a choice of windows to share.
There we go.
There you go. Yes.
Okay, brilliant. So this person does not exist.com. All it does is every time you refresh the page, then it creates a new person. And as you can tell from the the name of the website, this person does not exist. So this person does not exist. It's just been generated by a computer using generative adversarial I forget the word, networks, whatever. So and these are pretty good sort of fake people, right? So if I just saw this picture out of the blue, I'd probably think, well, this person is a real person, right? And this lady is a real lady. And they're very difficult to tell that they're fake most of the time. So, but there are some giveaways often that I've noticed. So even though most of the sort of center of this person's face looks real, if you look at the ear at the side, there's sort of some weird bits going on in the corner. Also, just above the sort of eyebrow, there's a weird bit going on there, and around the hair. So they're not completely perfect, and sometimes they're better than others. But computers are surprisingly good at creating these new things that just don't exist before. So what's the intuition? So how might these things, how might a computer be creating these, these fake people? Now I hope you can see my slides again. So back to the intuition. So what happens is it's a bit like, imagine a counterfeiter who's trying to create fake banknotes and a cop that's trying to catch them. So what happens is the counterfeiter comes up with a banknote, and then the cop looks at their banknote and looks at other banknotes and tries to work out, well, is this a fake banknote or not? If the cop catches, then the counterfeiter has to make a better one next time because they don't get any money if they get caught. But similarly, as the cop starts seeing fake banknotes, the cop starts getting better as well, because the cop learns that the counterfeiter, well, here's what's wrong when a counterfeiter creates a fake banknote. They're not very good at this particular part. So if I'm trying to find a fake, I need to look at this particular part. A bit like I pointed out that the ear on that image was not perfect when you look at it. So the counterfeiter is trying to make better banknotes that the cop is trying to get better as well. And they're both competing against each other all the time. And that's what happens in this generative adversarial network, is that one network, which is the generative one, tries to create an example. So it could be an example of a person, or an example of well, let's just say an example of a person. And then the other network tries to work out, well, which one is a fake person? So given that they get given this fake and a real one, can they tell which is which? Can they tell which is the fake and which is the real one? And if they can tell it, then the generative network has to get better next time so that it can beat the cop. If they can't tell, then the sort of the cop network needs to get better at telling which one's the fake. And they keep sort of fighting each other, the adversarial part. They keep training each other until the generative network is able to create such good fakes that the cop network, finds it really difficult. And that's when you show it to humans and you say, well, as a human, do you think this is a fake or not? And if you've got a good adversarial network, then even the human can't tell which is which. This is sort of very cutting edge in deep learning. So I talked about, it's possible to create these deep fakes. So here's an example of a company that created a deep fake of Mark Zuckerberg. I don't know if you'll be able to hear the sound.
Imagine this for a second. One man with total control of billions of people's stolen data, all their secrets, their lives, their futures. I owe it all to Spectre. Spectre showed me that whoever...
So this was just one example. So what happened was Mark Zuckerberg just gave an interview to CBS News at one time. And then some people used, some artists, in fact, because they wanted to demonstrate that this stuff is possible. They used this deep learning software to get Mark to say things that he never actually said. So if you look this up at the link below, you can see the full video. And they got a bunch of other celebrities as well, all saying things that they didn't actually say. If we're talking about ethics, this is a very interesting area for the future, and obviously incredibly powerful technology because it is sort of creating new things that just don't exist before. Okay. So there's a question here. Isn't it the learning component of machine learning that differentiates it from rule-based machine learning, which is better at prediction? So I'm not entirely sure what you're getting at here, but I think it's something to do with, so machine learning in the past was very rule-based, where you said essentially to a machine, let's say you're doing object recognition. So you've got a picture of an object and you're trying to recognize what is this a picture of. You're trying to teach a computer to recognize what a cat looks like. So in the past, what would happen is the machine learner would say, well, I think when a computer is looking for cats, then it needs to look for pointy ears and it needs to look for whiskers and it needs to look for fur and all the things that a computer scientist, the machine learner, thinks that a computer should look for. So these are the rules you should look for. But with the latest AI and machine learning, what they do instead is they just throw all the data in and the computer learns what it should look for. So it learns somewhere within this neural network that's created, it learns that, whiskers and ears and all the rest of it are important. And what tends to happen is the computer finds things that even, that the computer scientist wouldn't have recommended. So the computer finds its own features to look for. And that's a big reason why deep learning and, machine learning has come a long way in the last six years or so. It's getting the computer to find its own features. In order to do that, you need a lot of data. And that's another reason why this has happened in the last few years. So you need literally millions and millions of pictures of different objects in order that a computer can eventually learn to distinguish what objects look like. And that data just wasn't there in the past. Okay, so let me just check how I'm doing for time. Okay, so not too bad. So I'll go on
about
until
5 minutes left, David, and we'll cut it off at about 59 past.
Okay, I might go a little bit longer, Dave, if I may, just because we started late.
Sure.
Okay, so just a couple.
Appreciate that, sure.
Okay, well, at this point, let me switch to, I promised that I would show you R and what it looks like when a data scientist is doing some data science or getting some data. So I'm going to just escape and switch to my other window with RStudio. Okay, so hopefully you can see on the screen, this is my RStudio window. So this is what a data scientist probably spends, hours or, most of the day looking at. So this is what it looks like when, when they're actually doing this stuff. So as I said, this isn't to teach you to be a data scientist, but let me sort of point out some of the things that are going on the screen here. What I've got in the top left box is some code that I'm going to run in a minute to get some data from Twitter. So I'm going to do what one should never do, which is a live demo. So we'll see if I can get some data from Twitter or not. Sometimes the code works, but sometimes it doesn't. But hopefully it will this time. So that's my code that I've been writing. On the bottom left, when I start running my code, so when I start pressing this run button, the code is going to sort of get shown here, and some of the output from the code is going to be displayed. So you'll see that start to change as I start to run some of the code. In the top right, there's all the variables that I've created. So all the sort of data that I start creating, or all the things that I set get stored there. And then in the bottom right is my, various information, but for this demonstration, there's going to be some plots appearing. So you can see some pictures of the output of these analyses. So what would normally start is I'd put in my password. But I put on my password before I started this. Otherwise, you guys would see my password. So I can just run these 2 lines of code here. So you can see at the bottom left, these are the 2 lines of code that I ran. And you can see there's an output using direct authentication. So this is what Twitter has sort of returned to me when I logged into Twitter with my various passwords. So then the next thing I'm going to do is this line here is I'm going to get data from Twitter user who's called David_Stilwell, which happens to be my Twitter account. I could put anyone else's Twitter account in, and it would get information from their Twitter accounts. So when you use Twitter, it's by default it's public, so anyone can go along to your Twitter page and see what you've been tweeting about. So when I run this line of code, it gets some data from Twitter for me. And if I run these lines of codes, this is the kind of data that's collected. So for example, here you can see tweet user $created. So this was when I created my Twitter account. So I've been on Twitter since 2009, March the 14th. This is the description that I've got on my Twitter. So lecture in big data analytics, blah, blah, blah. So if you go along to my Twitter account now, you can see that description on my profile. You can see the number of followers that I've got, and this is my profile picture that it's downloaded from Twitter as well. Imagine that you are a company that's got lots of customers, and you know what their Twitter accounts are. You could go using this kind of code. You could go through them one by one and say for each customer, get their Twitter data and start looking at that. All right, what this next code does is it goes and downloads my tweets. So previously we just downloaded my profile information, but now we're downloading the actual tweets that I wrote. You can see it took a bit longer, so there was this sort of stop sign in the corner. So it took a bit longer to get that data because there's more data, but it's now downloaded 208 tweets that I've written. And if I write here view tweets, then here is all the tweets that it's downloaded. So you can see the text that I wrote on the tweet. You can see how many people clicked the like button on that tweet. You can see when I wrote the tweet. So the last time I tweeted was on the 15th of October, so yesterday, and various other information that it's downloaded about these tweets. But the main one for our purposes is this text. So what have I actually written in my tweets? And again, just to repeat, I happen to be doing this with my tweets because I know what they look like. But I could put, real Donald Trump, to take a famous account, or anyone else's account on Twitter, and it would download their tweets instead. So then if I continue running the next lines of code, then, so this is the average number of characters that I write in my tweets. These are the number of words that I write on my tweets. So the median number of words is 19. This is a histogram of the number of words I write in my tweets. So you can see, the most common is about 19, 20, 21. Sort of, that's where there's a sort of a bulge in the distribution. These are the hashtags that I use. So in the bottom left, you can see, so the number of times that I use hashtags. So the mean number of times that I use a hashtag is 0.05. So basically I use one hashtag in every 20 tweets. So I'm not a big hashtag person. But you can see the most common hashtags I use. So hashtag big data, also stuff like people analytics. And this was Times Higher Education, a conference that I went to. So you can see the hashtags that I use. And then these last lines of code get a word cloud of the various words that I've written and how common they are. So, and that's obviously appearing down the right-hand side on this plot section. So you can see that, I do big data stuff. So I talk about Facebook quite a lot. I talk about data. I talk about people, et cetera, et cetera. You can see all the other words that I use. And just to repeat, this could be created for any other Twitter account by running through the same lines of code. Just to sort of point out, there's probably, well, number one, people are quite surprised when I show this to them that you can just go out and get anyone's Twitter data. So if you are a startup and you're thinking, well, I don't have access to big data, so this is not relevant for me. Actually, there's all sorts of big data out there, and Twitter is one place you can get it, and it's surprisingly easy. And that's the related point here, which is that 113 lines of code is, for someone who knows about this area, it's not a horrific amount of code to write. And there are lots of examples on the internet. So it's the kind of thing that can be done even from taking someone else's demonstration online. It probably takes a couple of hours to convert it to something that can be used. So this is what data scientists are doing all the time, taking code that others have written, making tweaks to make it work with their particular use, and then applying it in their practice. Okay, so let me finish off with the Q&As that I may have not got to. So Graham says, is this Microsoft RStudio? Yes, it's RStudio. So if you do want to use R, then it's a programming language. So you download R and install it. And then this is a sort of a development environment. So this is something that sits on top of R called RStudio. That's one way to start developing things in RStudio. Could you please provide big data use cases for marketing and retail? So there are some examples in sort of big data section. So I talk a little bit about companies using, for example, weather data for retailing uses. Later in the ethics section, I talk a little bit about marketing, about how you can understand customers. So this is the kind of Cambridge Analytica stuff. So as part of the ethics, I'll talk about how does that work in practice. So there will be some examples coming up. So yeah, do look out for those on the course. Okay, so Monique asks, I'm aware of GDPR, but not on the detail. What data are companies allowed to hold on prospective clients through web scraping / open government data, etc.? Yeah, good question. And as you can imagine, the devil is in the detail. But in gist, if the data is anonymized, so if it's not personal data, so if it's anonymized well enough, then it's not personal data, then there aren't too many restrictions. So open government data, so most, the data that the government release in an open format is data that's been anonymized, so you can use that for whatever. If you're web scraping from different places, then it comes down to the extent, then you start getting into questions like, well, is this public data? And Twitter, for example, is generally seen as public data. However, there's still questions of, well, if you download someone's tweets and then someone tries to delete their Twitter, is that going to delete it in your database as well? So then you get to questions that are a bit tricky around, well, if you want to use someone's data, then making sure that you've got the most up-to-date version, and that if they delete their data, then you've deleted it from your company's data as well. So you start getting quickly into the sort of tricky details of making sure that you're getting consent from people, making sure that they can delete their data, making sure that they've got control over their data. But those two, as I said, anonymized data versus personal data is the first question to start with. Okay. Okay, so all right. So a great question from David, who asked much earlier. So apologies, just got it to now. The field of finance or financial economics has had lots of data for a long time. Oil prices, daily oil prices over years and years and years, or bond yields, minute by minute for years. People have used MATLAB to analyze this data, but results have been minimal. Parameters jump around depending on the period of analysis. Do you think other fields will be more promising? So yeah, I went to a conference on the use of machine learning and AI in finance last week, and various companies talking about what they're doing. One thing that surprised me is that the people I were talking to who were asset managers, they were saying, well, there's less than you think use of automated algorithms and big data and all the rest of it to make these sort of, fun decisions about what companies to buy and what ones to sell, especially when you're talking in sort of more medium or longer term, rather than just the second by second high frequency trading that goes on. So what they use the big data for is not to automatically make decisions. They use it as sort of another source of information. So, for example, that there's companies who have satellites looking down on car parks of big supermarkets in the US, and they count how many cars are in the car park. And then based on that, they say, well, either there's more economic activity or less economic activity. But then they don't trade based on that directly. It's just another piece of information that the asset manager takes into account, and then makes their fund allocation choices based on this. That surprised me, because it's not quite as data driven as I thought it was. They think it's important to have a human. The other challenge with the financial markets is that as soon as you use data to predict something, the very fact that you then start trading based on that means that it's sort of slightly less valuable. And if other people start trading on that, then it's just completely useless. The real challenge with financial markets is to use big data to predict something that no one else is predicting, not just, working with past data. So the world changes, and what predicts something in the past stops being able to predict it in the future, which is different from something like the weather. So, as you get better at predicting the weather, the way that the weather works doesn't change. The physical system, the physical algorithms behind the scenes, the physics stays the same. So you can get better and better and better with the weather. in a way that you can't with the financial markets because people are competing with each other. Okay, so we're at 10 past, I'm afraid. So thank you for your great number of questions. I've answered as many as I can. If I've missed any, feel free to send them to me. Last time I ran this course, I recommended sending me an email, but very few people sent me an email. However, people were very keen on adding me on LinkedIn. So you're welcome to look me up on LinkedIn and then send me a message there. And if I, I'll answer as best as I can. All right, so thank you very much, everyone. I don't know if you want to sort of sum up, Dave.
Sure. First of all, the adage "better late than never" I don't think has ever been applied more roundly than today. Thank you to David Stillwell. Professor Stillwell played two roles today, as you all have seen. Generally, we try to have at least two levels of support here, not just to introduce Professor Stillwell and get the conversation started, but also to help out with the ongoing Q&A dialogue. And because of a technical glitch, it took about 20 minutes to get us all happening on this end. And so one, I want to apologize on behalf of the course for the late start that had absolutely nothing to do with Professor Stillwell and everything to do with the platform behind it. And that looks to be resolved for the future, so that should not happen again. And second, just as advertised, as we've discussed in previous office hours, these webinars are really, this is exactly what we aim to do in these webinars, where we not only have the information exchange that you're getting through the traditional course delivery system, but the ability to have the direct Q&A, to really see the professors with their sleeves rolled up a little bit, is a privilege. So thanks again to David, and thanks to everyone on this call, all 50 plus of you, for your patience at the beginning of the call, and also for hanging with us in the end. We wanted to make sure you got your money's worth and got your full hour out of it. So again, with thanks to everyone, we will see you either in upcoming office hours. The next module will be released, of course. And then we will have, please keep checking the course calendar for upcoming faculty webinars throughout the course. We'll be back at it. And as David mentioned, the capstone webinar at the end of the course, I can't recommend more highly, which is when we do get to the place where we do talk about ethics and legal considerations, and it's very much present day. So again, once again, and as a clerical mechanism for anyone who joined late, first of all, the slides and recording will be available for the next 12 months, I believe. Just give us a few hours to get it all together. Also, if there were any calendaring issues, sorry to end on an administrative note, but if you had any issues with the calendar, kindly email the program support team with as specific mentions of any errors as possible. As I said, there were a couple of glitches that led into today's delay, and I'm afraid that might have manifested itself on other people's calendars as well. We will get that fixed and we will move forward. So once again, you'll see the slides and recording on this webinar, and we will see you live at some point in the future. And a big thanks to David Stillwell and to everyone for your participation today. We'll see you soon.
Thanks, everyone.